today's video, we are going to continue on time value of money. So we are going to look at application of time value of money. We get to know how amortization of loans and sinking fund is done. So in a real life, the application of time value of money is done in two ways. That is amortization of loans and application of sinking fund. In terms of buying a future item or in terms of saving to buy a future property or saving to achieve a future goal. So when we talk about amortization of loans, so we are saying that you go and borrow a loan from the bank, and at the end of the day, you have to pay that loan that you go and borrow plus the interest that will be accrued on the loan. So in your repayment of that loan, you pay the interest amount and also you pay the principal amount. So amortization of loans enable us to be able to know how much you should pay on a periodic basis to be able to cater for your principal and the interest that is accruing on the principal amount that is borrowed, right? So that is what amortization of loan or amortization of what you've gone to borrow seeks to solve. So we are looking at the periodic amount which you should pay to be able to cater for the principal and the interest. So the formula that you use is your present value times your interest, right, over 1 bracket open 1 minus bracket open 1 plus your interest bracket close to the power minus n bracket close. So the same formula, so it's like we are using the present value formula. So we know that our present value is equal to our periodic payment bracket open 1 minus bracket open 1 plus r bracket close to the power minus n all over r. So we are using this formula. So in this case, we are using this present value formula. Then we know our present value, we know our interest. So we are now trying to get the periodic amount which should be paid in order to cater for the loan, which is the interest and the principal amount. Under amortization, we have how each payment is structured, right? So we have early payment, right? So that means you are making the payment early, and in that case, you are taking care of large interest and you are making small payment towards the principal, right? And we have late payment, right? So late payment means that you are making payment towards the payment you are making towards your interest is very small, and the payment that you are making towards your principal is very large. So throughout the loan, we know that the periodic payment that you make is constant, it doesn't change. So that's why we use amortization schedule to be able to tell how much should be paid periodically in order to cater for the loan borrowed or amount borrowed, which is your interest and the principal. So we now have the steps to amortizing a loan. The first step is that you calculate the payment per period. So in this case, you are using the present value formula to be able to get your periodic payment that should be done. In this case, you are using your periodic payment is equal to your present value, right, times the interest all over 1 minus 1 plus r to the power minus n. So this is the formula. So this formula is the same as this formula, right? So in getting your periodic payment, you use this formula, right? Then the second step is that you have to determine the interest in each period, right? So when you are doing the amortization schedule, you have your opening balance, right? You have your interest. So every time you have to determine interest per period. Then the third option, so in this case we are saying that the interest times, so we now have the the balance as at the period times the interest amount, right? That is to the opening balance. Then the step 3 is compute the principal payment in the period, right? So in this case, what you do is that you now have your opening balance, then you have your interest, then we have our periodic payment, then you now get your principal repaid. So yes, we have to get your principal, and in getting that, it has to be your payment minus the interest. So the next step is that determine the ending balance in the period T. So in each period, you have to determine the ending balance. And in determining the ending balance, you now have your opening minus your principal repaid, right, to get your ending balance, right? Or another person can say that you take your, so another person can calculate in this way. You take your opening balance plus the interest minus the payment, then you now get your ending balance, because you take your opening balance, you get you accrued interest on it, and you subtract the payment that you have made, and you now get your ending balance. Step 5 is that repeat step 2. Use the new ending balance as the opening balance for the next period. So you repeat step 2, right? So you repeat step 2 to step 4. So let's look at this example. A company purchased a piece of equipment for its production department at a cost of 37,500 on 1st August 2017. It is anticipated that this equipment will be replaced after 5 years of use on 1st August 2022. So the equipment is purchased with a 5-year loan, which is compounded annually at 20%. The loan will be paid off in equal annual installment. So the first requirement is to determine the size of the annual equal payment. So that's the first requirement. The second requirement is to prepare an amortization schedule showing the amount outstanding and the interest for each period of the loan, right? So that is the example that we are going to look at. So based on the question, we know that the loan that is being taken is 37,500. Then the number of years is 5 years. The interest compounded annually is 20%. But in this case, we don't know our periodic payment, but we know that our present value formula is our present value is equal to our periodic payment bracket open 1 minus bracket open 1 plus the interest R, which is the interest bracket close to the power minus n all over R, right, bracket close. So in this case, we now know our formula for our present value, so we can now make our PMT the subject, that is our periodic payment the subject, because we are looking for that amount. And in doing that, we'll now multiply our present value times our interest, this interest, right, all over this portion. So we'll now have our present value times the interest all over 1 bracket open 1 plus R bracket close to the power minus n. So this will be the formula to get our periodic payment. So after quoting this formula, you can now fix in the various values for each variable, right? So we know that our present value, which is the PV, is 37,500 times, we know our interest to be 20%. We know our interest to be 20% over 1 minus bracket open 1 plus 20%, which is the interest, bracket close to the power minus 5. So here the 5 is the number of years. So when we use our calculator, we multiply 37,500 times 20%, we'll now get 7,500. Then when we use our calculator to solve 1 minus bracket open 1 plus 20% bracket close to the power minus 5, we'll get 0.5981. So when we use a calculator and you solve this, you'll now get 12,540. So that means our periodic payment that is going to be made is 12,540 Ghana cedis. And the second question is, we should do amortization schedule to show how this payment of the loan will be done. We know that through the first year we know that our present value is 37,500. Then our interest will be the 8%. So in doing the amortization schedule, so we know that at year 1, our present value, which is the starting amount, that's the loan that we've taken, is 37,500. Then our interest will be our interest rate, which is 20% times the A. A is the opening balance. So 20% times 37,500 will give us 7,500. Then our B will now be the annual amount that we've calculated. The annual amount that will be paid on a periodic basis that we've calculated. And we know that that amounts to 12,540. And this amount will be the same for each period, right? Then our principal repaid, which is a C, will now be our B minus our interest. So here is our B, the principal annual payment minus the interest, which will give you our principal prepaid, right? Then our closing balance will be our A, which is the opening balance minus our principal prepaid, right? But someone too can also take the opening balance plus the interest amount minus the amount, the annual payment, to now get our closing balance, right? So you do that for each year. So year 2 you know that at the end of year 1, our closing balance is 32,460. So which will be the same value for year at the beginning of year 2. Then we'll now calculate our interest on it, which is 20% times 32,460. Then you now get 6,492. Then we the same annual payment, which is here. Then our principal amount will be the 12,540 minus 6,492. So we now get 6,048. So our closing balance, which will be our opening balance minus the principal prepaid, we now get our closing balance to be 26,412, right? So you do the same thing for the 3rd year, right? And you do the same thing for the 4th year. So when you realize that at the beginning of year 5, this will be our opening balance. Then we'll calculate 20% on. So calculating 20% on it, you'll get 2,089. So in doing that, it means that our annual payment will still be the same, and our principal prepaid, which will be our interest, our principal prepaid, which will be our annual payment minus the interest, you will now get our principal amount to be 10,451, right? So which is the same as just some insignificant difference, but it's almost the same. But this one is 10,445, and this one is 10,451. So like some 4 difference, right? Which is insignificant. So at the end of the day, the total interest paid is 25,194, right? So that is so. In this case, you realize that at the beginning, you are at the beginning of the period, your interest amount is large, but at the end, the interest amount is very small. And you realize that at the beginning, your principal prepaid is small compared to at the end, the principal prepaid is large. So let's look at example 2, right? So the same company, which is company E, wants to accumulate enough fund over 5 years to replace equipment at an estimated cost of 80,000. A bank offers 15% per annum on deposit. How much must it deposit annually? So the question is, the company wants to accumulate an amount of money in 5 years to come, and they estimated that the cost of it to replace an equipment, right? And they estimated that the cost of the equipment is 80,000. So to do that, they want to know how much they should deposit in a bank account to be able to cater for that 80,000. Yeah, so let's look at question 2. We know that from question 2, right? From question 2, we are finding our periodic payment amount, right? And we know that our present value is 80,000. Our interest rate is 15%, all over 1 bracket open 1 plus 15% bracket close all to the power, the number of years is 5 years. So we now get 12,000 over 0.5082. So we now get our periodic amount that the company should deposit to be 23,630. So let's look at sinking fund. Right. So sinking fund means that you have a future objective that you want to achieve, or you have something in the future that you want to purchase. So because of that, you are depositing an equal amount in a fund or in an investment account to be able to achieve this future objective, or to be able to purchase this future item as a company, right? So we are making an equal payment to achieve a lump sum in order to replace an asset. So you know that you have a future target that you want to get, and you have to make a periodic deposit to be able to get that. So common uses of sinking fund, right? So it is used for corporate bond redemption. You accumulate fund to repay bondholders at the maturity date. So it's also used for equipment replacement. You save for future machinery purchases. So you set aside fund to retire a long-term obligations. So sinking fund is the reverse of future value of annuity. So this one too, the formula is our future value times our interest all over bracket open 1 plus r bracket close to the power n minus 1. So we know that our future value formula is equal to our PMT bracket open 1 plus r bracket close to the power n minus 1 all over r. We will now make our PMT the subject. So that's how you're able to get PMT is equal to our future value times our r all over 1 plus r to the power n minus 1. So let's look at a quick example. A company needs 500,000 in 8 years to replace a machine at interest rate of 10% per annum. How much must it deposit annually? So we know that our future value in 8 years is 500,000 at an interest rate of 8%. So how much must he deposit annually? Right. So in doing that, we know our future value times our interest is 10% all over bracket open 1 plus 10%, which is the 1.10 to the power 8. How many years? 8 years minus 1, which you get to 500 over 1.1436. You will now get a monthly deposit of 43,722. So let's look at this example. We know that assuming a customer instructions to the bank was that the first transfer should be made now, followed by so the same amount of 400 Ghana cedis for 3 more years at an interest rate of 15%. What is the size of the account after 4 years? Show a sinking fund schedule to show the growth of the fund. So from the question, we know that our periodic deposit is 400 Ghana cedis. For how many years? 4 years at an interest rate of 15%. And we know that our future value formula is our future value is equal to our periodic payment bracket open 1 plus r to the power n minus 1 all over r, right? But in this case, because this one was done at the beginning of the year, the payment is done at the beginning of the year. It means that you have to still multiply it by 1 plus r, because it will have one additional year of interest. So we can now fix in our values. We know that our periodic amount is 400,000 bracket open 1 plus 15% bracket close to the power 4 minus 1 all over 15% bracket open 1 plus 15%, right? So using your calculator, you now get your final value to be 2,297 Ghana cedis. So the account size at the end of the 4th year or the 4 years period, it will be 2,297 Ghana cedis if they make a periodic payment of 400 Ghana cedis at the beginning of each year. So let's look at the sinking funds. So we know that we have the years, we have the opening balance, we have the interest, we have the annual deposit, we have the closing balance, right? So the number of years is 4 years. So we have year 0, 1, 2, 3, 4. So at year 0, that was when the deposit was done, but at year 0, we are not getting any interest. So at year 1, we still have that deposit that was made at year 0. Then you calculate our interest of 15% on it, so you get 60. Then we know that we are making a periodic deposit of 400 Ghana cedis, so it runs through to the end of the period, right? So now our closing balance will now be our opening balance plus our interest amount plus our deposit will now give us our closing balance. So the same thing, the closing balance will now become the opening balance. You calculate your interest of 15% times the opening balance, which is 860. You now get 129. Then we are making a 400 periodic deposit, which at the end of the year, our closing balance will be 1389. So you do the same thing for year 4. So you know that because this one is done at the beginning of each year, you realize that at the closing of year 4, our deposit is 0 because we are done the deposit at the beginning. So because of that, you calculate interest on the opening balance, which you get 300. So when you add that 300 plus 197, the deposit is 0, you now get our total balance to be 2,297, which is the future value that we are expecting to get from the annual deposit amount of 400 Ghana cedis.